This is Sreevani. I am working as an assistant professor in S.A.Engg.College. Today I am going to take lecture on the topic Q in data structure. So before we are going to discuss about the Q, first we will see one real-time example. Here I have taken the real-time example as movie ticket counter. So if you observe the diagram is clearly, so you have two ends. So from this end, the person entering into the ticket counter and he is receiving the ticket, then he is leaving from the counter. It means here you have two ends. So one end you are going to use for entering purpose, another end you are going to use for leaving purpose. The same concept only you are going to implement in the queue. So here also you have different types of queues you have. So simple queue or linear queue, the second queue is circular queue, the third one is a priority queue, and the last one is a double-ended queue. So first we will start with the simple queue or linear queue. So it is a linear data structure. Here you are going to organize the elements in sequential manner. If you see the simple queue means, here I have represented the simple queue. So if you observe the diagram clearly means here you have two ends. One is a rear end, another one is a front end. Rear end always we have to use for insertion purpose, and front end always we have to use for deletion purpose. So these are the basic operations we can perform in the queue. Is empty operation, is full operation, NQ operation, DQ operation, peak operation. Is empty operation. What is the purpose of is empty operation means in order to know whether your queue is empty or not. So is full operation is used in order to know the status of whether your queue is full or not. So NQ operation is used to insert an element in the queue. DQ operation is used in order to remove an element from the queue. So peak operation is used in order to get the value of front without removing from the queue. First we will start with the is empty operation. So here I have given the algorithm steps for is empty operation. So if you have to know whether your queue is empty or not means you have to check the rear value, front value. So if your rear value, front value is -1 means you have to say that your queue is empty. If it is not -1 means you have to say that it is not empty. Next one is full. When you will say that your queue is full means if your rear value reaches the maximum size -1, that time you have to say that your queue is full. If it is not reaches the maximum size -1 means you have to say that your queue is not full. Next one is NQ operation. NQ operation is used to insert an element in a queue. So before you are going to insert an element in a queue, you have to check the overflow condition. How you will check the overflow condition means if your rear value is reaches to maximum size -1 means you have to say that your queue is overflowed. So here you have to print the message as your queue is overflow and you have to exit from the queue. If it is not full means you have to increment your rate pointer. Then only you have to insert your new element. From where your rate pointer is pointed, in that particular place only you have to insert your new element. I have given one example. Here red arrow mark I have used for front pointer and blue arrow mark I have used for rate pointer. Initially my queue is empty. When you will say that your queue is empty, already I said to you, if your front value, rear value, both you have to mark as -1 means your queue is empty. So when you are inserting the element, that element is the first element means both the front value, rear value, both you have to increment +1. Already the value is -1, so -1 + 1 is the value is 0. So both the front value, rear value you have to point out to the 0, then you have to insert the element 7. Again I am going to perform NQ operation. So I am going to insert the element 2. So third time you have to use only your rate pointer. So here my rate pointer I have incremented, that is before my rate is pointed to the 0th position. Now you have to increment by 1. So I have incremented by 1. In that place the new element 2 is inserted. So again I am going to perform NQ operation. So again if you want to perform NQ operation means you have to use only your rate pointer. So I have incremented, before my rate pointer is 1. So you have to increment. So you have to increment means 1 plus 1 is 2. So at position 2 you have to insert the value minus 9. So here you can insert the positive values, you can insert, as well as negative points also you can insert. Next one is DQ operation. DQ operation mainly used in order to perform the deletion in a queue. So here you are going to perform two subtasks. First one, before you are going to delete an element from the queue, first you have to access the element, then you have to delete it. So before you are going to delete, you have to check another condition, that is underflow condition you have to check. Why means if you have an elements in a queue only you can perform the DQ operation. If there is no element means how can you will delete the element? You can't delete the elements. So how you will check whether the queue is empty or not means if your rare value, front value both are minus 1 means you are going to say that your queue is empty. It means you cannot perform any DQ operation. If it is not empty means you have to perform two tasks. First one is first you have to access the data from where the front pointer is pointing. That data first you have to access it. Then you have to delete the element. After deleting element you have to increment your front pointer. Here I have given an example. Here red arrow mark indicates the front pointer and blue arrow mark indicates the rate pointer. Here in this example I have taken three elements. One is 7, 2 and 9 which we have used in NQ. Same elements only I have used in the DQ. First I am going to perform the DQ operation. It means which element you have inserted first, that element only you are removing first. And when you remember that when you are performing DQ operation you have to use only front pointer. So first you have to access that element, then only you have to remove the element. So I have accessed my element, then I have removed it. Once you have removed the element means you have to increment your front. It means you have to point out to the 1. So again second time I am going to perform DQ operation. So when I am going to perform DQ operation, first you have to access the element 2, then you have to delete it. So once you have deleted the element means the front pointer you have to point out to the next element, that is 2 you have to point out. So from the 2 position what is the element there, first you have to access the element, that element, then you have to remove it. If you see here means the front pointer and rate pointer both are pointing to the same position, means third time it meaning that your queue is empty. So if your queue is empty means both the front pointer and rate pointer you have to mark to the minus 1. So one of the drawback presented in simple queue, that is you are going to perform insertion only by using the rare end. So this is the one of the drawback presented in the simple queue. How means for example I have the queue. In my queue I have 4 elements, that is first value, second value, third value, fourth value. These are the elements presented in my queue. So you have 2 ends, one is rear end, another one is front end. Rear end you are going to use only for insertion purpose and front end you are going to use for deletion purpose. So if I perform DQ operation, first step means the first element will be deleted. If I perform second step, again DQ operation means the second value will be deleted. If I perform third time also DQ operation means the third element will be deleted. In fourth time, if I perform the NQ operation means third time it will say that your queue is overflow. But if you see means the first position, second position, third position is empty, but still it's showing that your queue is full, because rare pointer alone you have to use in order to perform the insertion. So this is the one of the major drawback presented in the simple queue. To overcome this drawback, they have introduced the concept as circular queue. Okay. So circular queue, it is very similar to the linear queue except the last node connected to the first node. It is also called as a ring buffer. So here all ends they are connected to the each other. Next one, DQ. DQ, it is also known as double-ended queue. In DQ, you have two ends. One is front end, another one is rear end. In front end, you can perform insertion and deletion. In rear end, you can perform insertion and deletion. It means in both ends, you can perform insertion and deletion. You have two types of DQ. One is input restricted DQ, another one is output restricted DQ. First we will see the input restricted DQ. So as the name implies, you can understand that something restriction is there in your input. It means you can perform insertion only one end. It may be a front end or it may be a rear end. So if you are performing the insertion at front end means you cannot use the rear end. But the deletion you can perform in the both ends. Next one is output restricted DQ. As the name implies, you can understand that you have some restriction on your output. It means so insertion you can perform in both ends, but deletion you have to perform only one end. It may be a rear end or it may be a front end. Next one, priority queue. So here it is a special type of queue. Here you are going to arrange the elements based on your priority. If you see this example means, so this is a queue. You have two ends. One is front end, another one is rear end. Front end you are going to use for deletion purpose and rear end you are going to use for insertion purpose. Here you have arranged the elements based upon the priority. Here I have taken my highest element as my priority. It means you have to arrange the elements from decreasing order. Next, applications of queue. Here I have given some real-time scenarios. Printers and single shared resource is one of the application. Next one is operating systems for task scheduling. Switches and routers, call center phone system. These are the some real-time scenarios where we are using queue. So here I have given some gate questions. The first one is how many stacks are needed to implement a queue? Consider a situation where no other data structures like arrays, linked list is available to you. So to implement a queue, you need two stacks. Why means one stack you are going to use for performing NQ operation, another stack you are going to use for DQ operation. So the answer is 2. The next question is which of the following is not a common operation in a queue data structure? If you see here means NQ operation we are going to use in a queue for insertion purpose, so it is available in the queue. And DQ we are going to use in order to perform the deletion purpose. Pick we are going to use in order to get the front value from the queue without deleting it. And shuffle, it is not going to use in the queue. So your answer is D. Next question is which of the following data structure is available for train ticket in a waiting list? Train ticket means first come first serve. So if you see this stack means there you are going to use the principal LIFO. If you see this stack and queue means you are not going to use any principal. So if you see the queue means there you are going to use first come first serve principle. So your answer is Q, that is B. Next one is in queue inserting elements beyond capacity of the queue which result in an exception known as beyond capacity means overflow condition condition you are going to check it. So your answer is B. Next question is 5 people P, Q, R, S and T. They are standing in a queue or standing between P and T. P is just behind Q and Q is second in the queue. Who is the second last in the queue? So for this, first they are saying that are standing between P and T. You have P and T. Between P and T, R is standing. This is first possibility. Second one, T, P. Between that, R is standing. This is second possibility. Next they are saying that P is just behind Q. So just behind means you have this option. You don't have this one. Next one is what? And Q is second. So Q is second means the next element is, the next person is what? S. So S will come first. So Q is presented second means the first element will be the S. So now they are asking that who is the second last in the queue. This is your queue means who is last to second R. So your answer is C. Next one is so in which of the following data structure both insertion and deletion can perform at either end of the data structure. So you have only one option, that is DQ. In DQ alone you can perform insertion and deletion operation at both ends. So the answer is A. Conclusion. Q is used to manipulate the different data types, and also we can perform various operations, that is NQ, DQ, is full, is empty and peak. So it is recommended to apply the Q when there is a need of for the FCFS. That means first come first serve.